This special Aeronautics and Space Report brought to you by NASA. The gap between drawing board and the time before a new plane is certified to fly has always been considerable. Now, with the help of computers like these in the Computer Graphics Lab at NASA's Ames Research Center, this gap may be shortened. The computers, some capable of three-dimensional visual displays, are available to help researchers deal with a wide range of problems before going to the expense of building a plane or even a wind tunnel model.
What we're looking at here is the ability to actually view real objects, that is, three-dimensional objects and scenes, the way they would normally appear to you if you were looking actually out of a window, say. The operator sitting at the console is able to control through the pencil-like device he has in his hand the viewing parameters on how he would like to view the scene. And as you can see, he can actually change his viewing angle by moving the pencil-like device on the data tablet to, say, go above the scene and look down on the airplanes, or going down where he's looking up at the aircraft, or in fact actually rotating his chase plane, if you will, around the aircraft in formation. This is only a demonstration program of the capabilities of the hardware, but it is a great aid in enabling the investigators, the research scientists here at Ames, better understand some of their problems when they're three-dimensional in nature.
Air trailing over the wings of planes in flight, especially large planes, forms tornado-like patterns called vortices. Because the FAA requires minimum separation distances between aircraft, the vortices do not present a danger. They do, however, limit the number of airplanes that can take off and land within a given time. The problem is one that researchers would like to eliminate, and it can be studied using the computers.
We see a 747 flying away from us. The researcher has positioned some vortexes at the various places that they are created in an aircraft. Notice the flaps, the ends of the wings. He would like to see how these surfaces or the vortexes interrelate with one another as the plane moves away. You can see the vortices on the back wings move clear down underneath the airplane. It is hoped that doing this computationally will save wind tunnel test time to determine what modifications might be made on the wing, the flaps, the engines, so forth, to minimize the turbulent flow that results behind the aircraft.
Researchers are also using computer graphics to study how life might evolve on another planet, such as Mars. Here, a molecule described in 3 dimensions.
It's only through the use of these three-dimensional displays could the researcher have any idea at all on how these complex shapes interrelate, how they might have connected in years gone by. And through this mechanism, we hope he'll have a better understanding of some of the life-building processes that went on millions of years ago.
This is NASA's Goldstone tracking station near Barstow, California. Normally used to communicate with interplanetary spacecraft, the big 85-foot Venus dish, as it is called, is now also serving as a research tool to study the problems of beaming converted solar energy from a satellite in space back to Earth, where it can be reconverted to electricity. For the test, the 85-foot antenna represents an energy satellite. From its vantage point in space, it would collect and convert sunlight energy into electricity. A mile away, a 25-foot high set of receiver panels called the rectenna plays the role of a ground station. Made of aluminum, the more than 4,500 small rectenna elements are T-shaped and about 4 inches long. They work like a TV antenna to gather and filter the microwave energy, converting it to electric current that could be fed directly to a utility. On a hillside beneath the receiver tower, a bank of 17 lights begins flickering on, reaching full intensity as the power increases. The lights go off and on as the big antenna tilts up and down and swings right and left. Now on the rectenna, now off. The results have been very promising as Goldstone researchers successfully collected the microwave beam and converted it to usable electricity with an efficiency of 82%. This special report brought to you by NASA, the National Aeronautics and Space Administration.